Hello class. So welcome to this video on 1.7 homework from Savas. I want to go ahead and go over the 6 proof questions in this problem set. So for the first question, we're looking at 2 angles in the diagram, and they said that angle F and angle G are right angles, and we want to prove that they're congruent to each other. So this might kind of seem obvious. They're both right angles, and so we would say, okay, well, they're congruent, they're the same. But sometimes you got to prove your reasoning in between. So let's look at the steps. So because they're right angles, well, we know that they have to equal 90 degrees, right? And so for step 2, we went ahead and said, okay, well, measure of F is 90 and measure of G is 90. So that is the definition of a right angle. So the reasoning that we use there is that a right angle is 90 degrees. And so that is what is considered by definition, right? So we will go ahead and select definition. And so next we want to look at, well, we know that the 90 is equal to 90, right? So we know that they have to be equal to each other here, the measures. And basically what we did is, well, we know that 90 is equal to F. And so we just say that we have F here, and 90 is equal to G, and so we set it equal to G here. So this is sort of like a substitution where you say that 90 is equal to F and 90 is equal to G. So I'll show you this real quick, so you know what I mean. Basically, so we know that 90 is equal to 90, right? That's that's common sense, right? It's 90, the value of 90 is equal to 90. But we know that 90 is equal to this. And so we could substitute that in and say that this is equal to measurement angle F. And that's called the substitution. But we can also do the same thing here, right? We know that 90 is equal to this. And so I can replace that and boot that out and just kind of call it measure of angle G. And so that's my new equation, right? So that's by substitution. So that's what I mean by using the substitution. You can also call this the transitive property because it's very similar. A equals B, B equals C, A equals C. So you can also call this a transitive property technically as well. Okay. All right. So now we're going to the last statement. If the 2 angles are equal to each other, well, that means that they have to be congruent, right? And what is that definition? Well, that's the definition of congruent angles. Okay. So angles that are congruent have measures that are equal to each other and vice versa, right? And so that's the definition that we're using there. Okay, and we have went ahead and proved this angle. This is known, I believe this is known as the right angle congruence theorem or something like that, where it basically states that all right angles are congruent. Okay, so we just proved a theorem there. So let's look at the next example, a paragraph proof. So if angle N and angle M are congruent and supplementary, then angle N and angle M are right angles. So we want to prove that. Okay, well, we know that angle N and angle M are congruent because that's what it says in the problem, right? Well, if that's true, then we know that angle M has to equal to angle N by definition of congruent angles, right? Well, because angle N and angle M are supplementary, remember that supplementary angles add up to 180 degrees, okay? So that's what that word means. So by definition, we would say that when you add the angles together, well, that's equal to 180. Okay, so now we're going to substitute angle M for angle N in order to get this equation. So let me show you how that looks like. Okay, so because we know we have angle M and angle N, right? We know that's equal to 180. But since we know that angle M, the measure of angle M is equal to the measure of angle N, well, that means we could do a substitution and we can replace this N with this M, right? So we can replace that with this. So that's what I'm going to do here. I'm going to replace that. And so now this guy is replaced with the measure of angle M, okay? And that's a substitution. So we did a substitution property. Now the good thing about this is that you can add those two together, right? So they're the same. They're both the same. So if you have one of these and another one of these and you put them together, that means you have a total of 2 of them. You're collecting them. So you have 2 of these guys. Okay? And that's what this says right here, that you have 2 of them. And so we have 2 of them is equal to 180 degrees. Okay? So let's go back to the problem. So this is equal to 180 degrees. And this is equal to, this is also equal to 180. So the division property of equality then yields. So then what we're going to do now is we're going to use the division property. So if we go back to the same question here, right, to the same, to the picture that I drew. Well, because we know this right here, and I'll write it, I'll go ahead and rewrite it over here. Because we know this on the right hand side, well then we can divide by 2 on both sides, and that's a division property right there. And if we divide by 2 on both sides, then we know that 180 divided by 2 is 90. And so by division property, that means angle M has to be 90. Okay, so let's go back to the problem. The division property of equality then yields that this is equal to 90. And then if we substitute measure of angle N for M, then we're also going to get the same thing. We're going to get it equal to 90 degrees because we know that M is 90 and we know that M is equal to N, and so it has to equal to 92. So now by the definition of right angles, that means that these 2, angle N and angle M, are right angles because they're equal to 90 degrees. And we're done with the proof, okay? Because we just said that we're trying to prove that they're right angles, okay? So that's it for that paragraph proof. So let's look at the next question. So it says, write a 2-column proof of the linear pairs theorem. What we want to do is, well, we have 2 angles, ABC and CBD. They're a linear pair. Remember that a linear pair means, so just to kind of illustrate that, remember that a linear pair means that when you have 2 lines that cross, then you're looking at the angles that are next to each other. So for example, angle 1 and then this angle, angle 2, the angles that are next to each other that are formed from 2 lines crossing, that is a linear pair. So this in red, those 2 angles in red are form a linear pair. Okay, so that's what that means. They're said that they're a linear pair, and then that means that they have to be supplementary. So that means that they have to add up to 180 degrees. Okay, so let's prove it. So we know that it's given that they're a linear pair. So then let's go back to the problem. So since they're equal to 180, well, since they're a linear pair, that means that they add up to 180. What reasoning do we have for that? Well, that's the linear pairs theorem. The linear pairs theorem states that if you have a linear pair, that means that the angles add up to 180. That basically that they're supplementary, okay? So that's the linear pairs theorem. So let's go ahead and check that. And because we know that they're 180 degrees, right, that they add up to 180 degrees, well, then they have to be supplementary because that's the definition of supplementary angles, that they add up to 180 degrees. So this is a really easy proof. There's only 3 steps here, okay? All right, that's it for that question. So let's move on to the next question here. All right, so write a paragraph proof of the following, for the following. So we have that ABC is equal to 114, DHE is 25, EHF is 41, and angle ABC and GHF are supplementary. So let's go ahead and let's take a picture of this to so that we can write on it. Okay, so we know that ABC, that's 114, DHE, this right here, that's 25 degrees. And EHF is 41. Okay, so that's just to make it a little bit easier to tell. So now by the angle addition postulate, so what is the angle addition postulate? Well, that's when you're adding 2 angles together. Okay, so if I were to take DHE and then EHF, well, then that gives me the total angle, and that means I got to add the whole thing. So to get DHF, DHF, well, I got to add the 25 and the 41 together. Okay, so I'm going to add these two together, and that's going to be my addition postulate. So 25 plus 41 is 56 degrees. Okay, so, or 66 degrees, apologize. So we're going to put 66 degrees here. We'll type that in later. Now, by the definition of supplementary angles, let's go back to the problem. So let's type in 66. So by the definition of supplementary angles, that means that DHF is supplementary to which angle? So remember that if you look at, so let's go back to the snapshot here. So because this is equal to 66, well, I know that 66 and 114 add up to 180. So 114 plus 66 is 180. Remember that two angles that add up to each other to get 180 is by definition supplementary angles. Okay, so these are supplementary angles. So that means that DHF is actually supplementary to ABC, this angle right here, because if you add those two angles together, you get 180. Okay, so that's what we're trying to get at. So DHF is supplementary to let's see here. DHF is supplementary to ABC. Sorry, ABC. So let's go to ABC. So ABC is 114 and DHF is 66 because the sum of their measures is 180. Okay, that's the definition of supplementary angles. Now, since blank is also supplementary to ABC, so what else is supplementary to ABC? Well, in the problem, it states that GHF is supplementary to ABC. Okay, so that's given in the problem. So since GHF is also supplementary to ABC, this means that DHF is also the same thing as GHF because DHF is supplementary and also GHF is supplementary. So that means since they're supplementary to the same angle, that means they have to be the same. So that means that they're congruent. And that's known as the congruent supplements theorem, okay? The congruent supplements theorem because we're talking about supplementary angles, okay? All right, so that is it right there. So some of these theorems are actually in the video, the first part of the video, I believe, maybe the first part or the second part. So it was in the video for the notes, but it kind of makes sense from the theorem. Congruent supplements theorem means that if you have two supplementary angles or two angles that are supplementary to one angle, then that means that they have to be equal to each other or congruent. So it's kind of in the name. All right, so let's look at next problem. Okay, so we want to write a two-column proof for this. So let me do the snip tool. There you go. Okay, so it says GFI is 152 and EFI is 48. Okay, so if we if we label that, so GFI, that's these two angles put together is GFI, and that is equal to 152 degrees. Now, using another color, EFI is 48. So EFI in blue is equal to 48 degrees. Okay, so that way we have a context. So now it says GFI is equal to 152. That's given. So if we were to take GFE and we add it to EFI, which is the blue, then that's going to give us GFI. Well, that right there is the angle addition postulate. So if you were to take this angle and you add it to the other blue angle, that gives you the red angle, the total angle. And that is known as the, angle addition postulate. Two angles add up to a big angle. All right, and then it says here GFE and EFI is equal to what? So basically using this angle addition postulate equation, well, we know GFI is 152, right? So we can replace that. We can actually replace GFI here with 152. And that is known as substitution. So we're actually using a substitution property right there. So let's change that to 152. substitution right there. Okay. So now let's look at the next part. So now it says GFE is equal to 9x minus 4. That's from the diagram. EFI is equal to 4x. So that's given. That's straight from the diagram. Okay. Now, because we know that that's what they're equal to, we can plug those into this equation right here. Okay, so we know that this is 9x minus 4, so I can plug it in here. And we know that this is 4x, that EFI is 4x, so we can plug that in right here. And so that's how we get this. That's the GFE right there. And this, that's the EFI. Okay, so that's a substitution that basically is what we did. We plugged in. So that's a substitution property. All right, and then what we're gonna do is we're gonna combine like terms, or we call it simplify. So you can simplify or combine like terms. So 9x plus 4x is 13x. Okay, and then we have minus 4. So I'll go ahead and kind of show you that just in case you're confused on how we did that. So the 9x and the 4x, that gives us 13x. Okay, and so that's how we have 13x there. All right. So we have that for combining like terms. And then next we're going to go ahead and add 4 to both sides of the equation. So we're adding 4 to both sides of the equation, and that's called the addition property. So we'll have 13x equals 156. And then the last step, we're going to divide by 13 on both sides, and that's called the division property. So 13x equals 156. That's the addition property. Next, we're going to divide by 13. That's called the division property. So we have to do 156 divided by 13. So we're going to do that. Let's do that on the calculator real quick so we can get that answer. So that's going to be 12. All right. And then we want to get to EFI. So remember what is EFI? Well, EFI is 4x. So we have 4 times x. Okay, so let me the picture here. So EFI is this guy, right? So we have 4 times x, and we said that x is 12, so we just plug that in. That's a substitution property right here. And so 4 times 12 is going to be 48. Okay. All right, and that is it for that question. So let's move on to the next question. We are on to our last question now. So another 2-column proof. So we have the measure of angle 2 is equal to 30. So let's actually go ahead and copy this. Okay, so we know that this angle is 30. And then it says angle 1 is 2 times angle 2. So what we're going to do is we're going to plug in this 30 into there. Okay, and if we do that, well, then that leaves us with 2 times 30, which is 60. Okay, so that's what we're doing here. We're 2 times 30, and that's a substitution property right there. Okay, and then 2 times 30 is 60, and that's called simplification or simplifying, same thing. And then angle 3. So basically, if we look at the diagram, we know that this is we said that this is 30 and angle 1 is 60. So then if you look at the diagram, you can tell that angle 2 and angle 3 are what we call vertical angles. Vertical angles are angles that are opposite of each other, and they're formed from 2 intersecting lines. Okay, so angle 2 has to be equal to angle 3. So angle 3 also has to be 30, because they're vertical. In the same way, angle 1 and angle 4 are vertical angles, and so angle 4 is also equal to 60. So that's called the vertical angle theorem. Okay, so angle 3 is equal to 30 because of the vertical angles theorem. Okay, and then what we do now here is we're just saying that angle 3 is 30, right? So we're replacing 3 with 30 in here. So we have 30 plus angle 4. So here's what they're doing here. I'll go ahead and paste that, copy that again. So what they're saying is they're starting there, and they're saying, well, okay, if I take the left side and I add, and they're basically taking the left side and they're adding the measure of angle 4 to both sides. That's basically all they're doing right there. And that's known as the addition property. Whenever you take an equation and you add the same thing on both sides, that's known as the addition property of equality. So when you write this out all over again, oops, let's cancel that. So if we were to write this out all over again, you'll get angle 3 plus angle 4 equals 30 plus angle 4. And these are the two that I added. So that's the addition property. So that's what they did. So we're going to addition property of equality. And then we know that angle 4 is 60. How do we know that it's equal to 60? Well, because of vertical angles. Remember we said earlier that we know that angle 1 is 60. And so by vertical angles, that means angle 4 also equals 60. So that's another vertical angle theorem. All right, we're wrapping up here. So now 3 plus the angle 3 plus angle 4, well, we know that angle 4 is 60, so then we have 30 plus 60 by substitution. And 30 plus 60 is going to give us 90, and so our final result is that we have it equal to 90. All right, so that is it for the problem set, guys. There's nothing else to the examples. So like I said, I'm going to take one of these questions and then I'll put it on the test randomly. And so I hope you learned something from this video, guys. Keep studying and do the best you can, and I'll see you in the next one.